mean of something or a standard deviation of something, if I were to add a specific value to it, does that adding, let's say we add 6 inches to our height by standing on a block or whatever, does that impact the mean, standard deviation, or both?
It only impacts the mean because you're pretty much just shifting the graph over.
Yeah.
So, like, on the number line. So, like, standard deviation would still stay the same, but, like, if you add 6 inches, then, like, your mean would increase.
Boom, you're exactly right. She said it perfect. Because if I think about it, if I add that 6 inches, right, that spread of the data stays the same. So we would say it only affects the mean, right? We also talked about, again, because we're going to bring this back up, so this is big concept to just pull out and remember. When we multiply or divide, what does that impact? Someone different. What does that impact? Campbell?
The spread.
Okay, good. So if I multiplied all of our values by, let's say I did it in inches, our height, right? And I've decided I'm going to multiply that by 2.54 to centimeters, right? In that instance, what happens to the spread?
Your data get more spread out.
It does get wider. And actually the standard deviation would then multiply by 2.54 as well. What about the center? What does the center do?
Just go with the multiply, yeah.
Yeah, multiplying and dividing impacts both center and the spread. Got me? Does that make sense?
Is this on the notes?
This is just pulling back from previous stuff. Does that make sense? So this was in chapter 2, if you remember. That's what we had talked about. When we multiply and divide, it impacts standard deviation and mean. But when we add and subtract, it only impacts center. Okay, Ella? Does that help you now? Kind of recap it? So this was chapter 2. Now, here's what happens, though. We have a little bit of something different. And to do this, what I decided to do was to give you a story, because I love stories, okay? Coach Jay, I know this is going to have a lot of jokes, especially today. I probably shouldn't say this. But Coach Jay has a hobby. This is a hobby I took on when I got married. One of my favorite things.
The lower end of the Christmas tree.
Oh man! Whoa,
Man, I tell you, this is going to be fun. This is going to be fun. I actually love woodworking. Like, I build stuff with wood. I know this is
That's not bad.
But you guys know elf.
What do y'all do? I knew this. That's not bad.
Maddie, did you make fun of me?
No, I didn't.
Oh, no.
You told me last week.
I know, I'm just
You
messing
said
with
He's
you.
proud of
Maddie
his
was
hobby.
fine. She wasn't saying anything. And then I have people call me Elf back here. What's up with that? So I literally, this is something I do, and it's pretty cool because I started doing this hobby, and I thought, I just kind of dabble in it a little bit, and I started getting like really into it to where like if my wife's like, man, I really want this piece of furniture, I'm like, I'm gonna build it, just how it is. Okay. So like this right here, this is a table that I built. So a lot of these are there. And so kind of give you the story, let's pretend that I actually go into a business, like a side business to sell these, okay? And let's say that this right here is our probability distribution chart. And this is the number of pieces that are sold by Coach Jay per month, okay? So the probability that I'll sell 0 a month, maybe that's during basketball season and it's really busy. That would be a probability distribution of 0.3, or a probability of 0.3, and so on and so forth. Now, to find this, we can do this by hand, can't we? And I think we did this on the podcast, where I multiply all of these together and add them together to get what we call the expected value. So what is the expected value for a random month for Coach Jay? Pick a random month. What is the expected amount that he would be able to sell? And we could do that and add them up, and that would be to find the mean, right? We could find the variance too, and you remember that on the podcast, and so on and so forth. But to help us, here's what we're going to do. We're going to help a little bit. Take out your calculator. I'm going to throw something here, okay? And you've done this before, which is kind of nice. Kind of nice here. Go to Stat and go straight to Edit, okay? And I'm going to clear all these out. Clear them. Okay. Clear these here. Okay. And I'm going to just plug these in the way that I see them. So right here, the value of X stands for the amount of pieces that I sold. So 0, 1, 2, and 3. Okay. Those are the amount of pieces that I could sell per month. Then I have my probabilities with each of those. So we're going to put 0.3 on L2. Not 0.03, 0.3. Okay. And 0.4 and 0.2 and 0.1. Okay. So I've got those there. Now, remember before how we did one variable statistics and we found like all the stuff that we needed? The other day on the podcast, I did it all by hand, which is important to recognize so that you kind of know the process, and that's important for maybe multiple choice questions, but that's not necessary. We can do it on here as well. So go to stat again. Once you plug those in, go to calculate and go to one variable statistics, okay, just like you did earlier. Everything's the same. Frequency list and everything's the same there, okay? Oh, hold up, my fault. Hold up, I did this different on the, go to one variable statistics, go to list, which is L1. Your frequency list would be what? L2, because that now brings in what? Brings in our probabilities that are there. And once I press calculate, we end up bringing up exactly what the values are that are there. So the L1 is the list. L2 would be my frequency list, okay? And that's how I plug it in and go from there. So what's my mean? 1.1, good. What's my standard deviation? 0.94. Here's what I would say. Find your mean, find your standard deviation, then find your variance. Got me? That's always the easiest way. So we go 1.1. Okay, so we'll plug 1.1 in. Got that there. The standard deviation was what? 0.94. And do you remember how we go from standard deviation to variance? Square. Good. So we remember, here's the deal. This is standard deviation. Here's the thing. Just a heads up, just a reminder, this is huge for the AP. Squared, the sigma squared or standard deviation squared is variance. So that's 0.88. Perfect. Okay? And again, that's what we would use when we're doing there. Now that's nothing new, right? All we learned there was one variable statistics and how to plug that in. Now let's talk about what happens with these specific random variables when we add or subtract different things. So let's do this. Let's just try to check it out. When we check Coach Jay that he makes $800 per piece that he sells. So on average, we'll just say $800 per piece, okay? Let Y be the monthly sales, and we're going to make a probability distribution for Y. So think of it this way. We're going to take each of these and do what with it? So multiply by 800, right? So the expected cost that I would get this month for 0 would be 0, right? What about for 1? 800, good. What about for 2? 1600, nicely done. What about for 3?
32. I was totally, that was
2400, right?
Hey.
I got you. What about the bottoms? What do we know about the bottoms here? Same thing, right? So we just keep it as 0.3, 0.4, 0.2, and 0.1. Now, here's the thing. Here's what I want you to look at here, okay? Because this is where a lot of this stuff is just quick, and this is really today is just checking things out, okay? Predict the mean. So we just multiplied by 800 based on what we talked about in chapter 2, okay? Let's predict what is the mean going to be here. So let's try it out. What do you think, if this is 1.1, we multiply by 800 here, what do you think the mean is going to be?
Can we just plug it in our calculator again with the G numbers?
We could, yes. But I want to just see if you can predict it first.
1.1 times 800.
Okay, 1.1 times 800, which is?
880.
880. Good. So we're just going to predict that it's 880. Okay, we're going to check it in the yellow in a second, like Campbell said. But just predict it. Let's see what happens. What about 0.88? 0.88 times 800, right? Because if we multiply, don't we also multiply by the standard deviation? So 800 times 0.88 would get me what? Someone throw that down.
774.4.
Nice. Good. I don't care if you made fun of me. That's a good job, Matthew. Nicely done. What about the standard deviation?
Hold on. It was just 0.88 times 800. Right?
Correct. That wrong?
704.
704?
Yeah.
Gotcha. 704. Perfect. What about the standard deviation? 0.94 times 800. What would you get there?
752.
752. Nicely done.
All right, James.
Good. Okay, so that's the predicted, right? You would predict that to be the case based on chapter 2. Now stick with me. Here we go. I want you right now in your group, one person, that's fine. I want you to plug this in. Just really all you have to do is change L1 and tell me what the actual values are, okay? Someone throw those in real quick. Tell me what the actual would be if L1 would be changed to these right here. Wes, you good?
Yeah.
Stay with me, okay?
Yeah.
What would it be the new things here? What do we do?
We were right.
We were right with every one of them?
No.
Let's try it. So the mean would be what?
We were right.
800, good. 880, I'm sorry, my fault. 880. What is the standard deviation? Because we do that next.
755.
752?
4.7.
755.
Maybe we messed up here. I think these should be the same, right? So 754.7?
Yeah.
Okay, so I think this should have been 4.72.
James.
On there, they should be the same. Okay, these should be the same.
Whoa, hey.
Question: what did we do though? Okay, what did we do to get to variance? How do I do that with standard deviation? We square it to get to what?
A big number.
It's large.
569,000.
569,
572.
572. Are these the same?
No.
No, so I would say this. Here's what I will say. Start with mean and standard deviation, then go to variance. Notice, I can't apply that rule to variance when I am multiplying or dividing by a specific value. Got me? Now, standard deviation, can we do that? Yes, we can apply chapter 2 rules to it, but with variance, you can't assume that you just multiply by whatever you multiplied up here. Got me? All right, you see what you just did? All right, any questions on that? Standard deviation and mean, you're Gucci. You're good on that, okay? You're good on that side. So when multiplying each value in a probability distribution by some number b, the mean is multiplied by what? Yeah, multiplied by whatever the value is. In this case, we'd say b, okay? The variance is multiplied by, now again, we go to standard deviation first, then square it, right? But it's going to be multiplied by whatever the b is squared. So when we talk about random variables, right, that's what our focus is. When we multiply by 800 or divide, then we have multiply by b for mean in standard deviation, and for variance, we multiply by b squared. If you're good, say uh-huh. All right, let's go to the next one, because this will be the next one here, okay? All right.
Amen.
All right, here we go. So on the top, suppose Coach J replaces equipment for one tool per month for $200, okay? All right, one tool per month. Z will be the total monthly income that you can make a probability distribution for Z. So question, this was 0, 800, 1600, 2400, right? But what would happen if I ended up taking this and saying, okay, I replace equipment for one tool per month for $200?
You just subtract that out.
I would subtract it out, yeah. So what would I get then?
680 for your mean. You subtract 200 from your 880. Is that what we're doing?
Yeah,
there?
from all of all the values of Z.
So if I replace $200 per month, I subtract 200 from what my initial one was, right? So wouldn't I have negative 200? What would be the next one?
Oh,
600.
you're going from straight 0?
600, okay? Yeah, well that one was, if you think about it, this was my previous one, right? Here's what my expected one is, but then I subtract what? 200 from it, right? Does that make sense? So we got negative 200, 600. What would be the next one? 1400, nice. And 2200. Very good, okay? What would be the probability for this one? 0.3. Next one? Nice. Point and 0.1. Nice. Okay, so we're going to predict the mean this time, okay? So what was the mean? Well, it was at 880, right? Okay, right, 880. If I subtracted 200, what would happen to the mean? What would we expect? 680, wouldn't it? Okay, because when we subtract, that we just subtract there, right? Same idea. What about predict the variance? Would I subtract the variance? No, it should be the same, right? Okay, so it should be the 569, 572. So let's put that there. 569, 572. And what was the standard deviation?
754.7.
754.7. Good. Okay? Those are our predicted. Let's see if we're right. Someone throw those down now, except L1. We're going to make this top list. Okay? Appreciate y'all for interacting. I know this is kind of heavy. We're trying to just discover it so I'm not just giving it to you. Not just giving it to you here. Okay? What'd you get there, Matthew? Minus 680.
Beast.
Variance.
Yeah, man.
Oh, standard deviation. I'm sorry.
Oh.
Same thing?
54.7.
So what would happen here?
Variance is gonna be the same.
It'd be the same, right? So
Dude.
we could just say this, that if we add or subtract, right, from a random variable, we're going to get back to what our predicted value is. The only thing is when we multiply by like 800, just be very careful. We'll follow the same type of rules with chapter 2, except for variance. So when adding the number 8, each value in a probability distribution, the mean is what? The same. Good. Or hold up.
No, it's subtracted by B.
Subtracted or added, right? So let's see what I got here. I throw in the notes. It's increased or decreased by A. Okay? Mary Martha, what about the variance? You said it. The same. Good. It is the same. Okay? All right. So this right here, that's kind of what we were headed to. Now here's where the kind of the rubber meets the road. What we did here was very similar to chapter 2 except the variance. Okay? The formulas that you see here, just a heads up, if I multiply a value by B, if I multiply the mean, like whatever random variable by B, it's the same as multiplying the mean by B as well, right? Okay? And with the standard deviation, or this is really the variance, got me? The variance, when I multiply by B here, okay, if I multiply the random variable by B, we're really multiplying by B squared. So we multiply this by B squared, okay? All right, do you want me to say it one more time? Okay? Think about it this way. If I multiply by 800, does the standard deviation multiply by 800?
Yes.
Yes, it does. Yes, it does, okay? If I multiply the variance, okay, if I multiplied all the values by 800, what would happen to the variance? It would be multiplied by 800 squared, okay? Now, here's the thing. What did I say earlier? It makes it a lot easier for me if I don't hop to variance and I just say, okay, find the standard deviation, and what do I do to go from standard deviation to variance? I just square it, right? That makes it a lot easier. Really, what are you doing? You're doing exactly this, okay? That's really what you're doing. So I think that's what makes it easier. Find standard deviation, then square it to find the variance. Ella?
What did you write for the first one? I can't read now about that.
Above, this is B times mu, which is our mean of X. So if I multiply all the values by 800, right? 800 per thing that I sell, then I'm just going to multiply the mean by B as well on that. Does that make sense? That's the basic one. Okay? All right, now here's where the rubber meets the road. We're going to go as far as we can in 7 minutes, all right? Mary Martha, you good?
Yeah, yeah, no.
Are you okay?
Yeah, no, I'm fine. I just was comparing. I'm good.
Gotcha. Mike,
No,
confusing you?
you're fine. I'm
Okay.
fine.
Cool. All right, let's go to this one. This is where the rubber meets the road. This is different, okay? We're going to go as far as we can, and then if we don't finish, that's okay. We'll hit it up on Wednesday. Come on. All right, let's do this. Let's say Coach J, the probability that Coach J sold the number of pieces from January is as follows. And this is the number of pieces sold by Coach J in February. Here's what I want to do. Grant, your group, and everyone to my right, I want you to do the mean, variance, and standard deviation for the top one. Got me? Someone come up and put it down. All right? Just in your calculator. Morgan, y'all, and anyone of the groups to my left, I want y'all to find the ones for February and put them on the bottom. Got me? I'll give you about. Y'all will be February on this probability distribution, man. Okay? So get it, put it in your calculator, put it up on top. Okay? Got it right there. You rock. Oh, that was the one we already had, wasn't it?
Yeah. Want me to read it to you, buddy?
Y'all rock.
Yeah.
Is it?
Wait,
do you see
I
like-
switched those.
So the variance is 0.8836. And then the standard deviation is 0.94.
Shout Max. You got a tough game this week? Thank you. Pretty easy.
Jackson.
Expert comes back in T-minus 2 weeks.
2 weeks, man.
T-minus 2 weeks.
Ready. I'm ready.
Phillips.
Did y'all get this here?
No.
You did?
Yes.
Matthew? Matthew, could you give it to me?
The mean is 3.4.
Okay.
Standard deviation is 489.
Yep.
Variance is 0.24.
Okay. Thank you very much. Okay, so heads up. We've got 2 random variables. Do you see that? The random variables we have, because there's 2 probability distributions, are for January and February. Okay? Now, this is where you got to really tune in. The other stuff, you could have kind of like, oh, we've done that in chapter 2. This is new. As we go to this, if I combine or add or multiply and divide 2 random variables, we're going to look and see what happens to it. Okay? So let's do this. What are the number of pieces sold for January and February combined? So heads up, X plus Y equals T. So here's what we got to do. Maybe I'm going to start you off with 1 and then I'm going to have you go. So if you look at the first one, I go back. If I were to combine these, I could have different possibilities of things that I could sell for January and February, right? What are the possibilities?
0, 1, 2, 3 versus 3 and 4.
Yeah, so I could say 0 plus 3 is what? 3. 1 plus 3 is 4. So I could have 3, 4, 2 plus 3 is 5, 3 plus 3 is 6, right? Good. It could be really anywhere from 3 to 4 plus 3, which is 7. Good, Matthew. So here's how you find the probability. 0 and 3. Listen to my wording. 0 and 3. What do I do with these two? Multiply them. Because think about it. 0 and 3. We multiply them because they are independent of each other. Okay? So 0 plus 3 is 3. 0.3 times 0.6 is what? See if I got it. 0.18, right? That would be 0.18. So we would say in this example that 3 would have a probability of 0.18, okay? All right, so watch this. This will be here. So 3 for the first one is 0.18, right? What about for the next one if we got 4?
There's 2 different ways to get 4. So.
Yeah. There's one where you have 0.12 and one where you have 0.24, don't you?
We
see that?
4 twice.
Yep, you could do it twice. Put it twice. Say that again.
Or just add them.
You could add them too, because you could have this or this. That's okay.
What's better?
I would just list them out, because that would just be, I think it would be better for you just to see all of them, but either way is fine. The next one is, there's 2 5s, aren't there? I think.
3 and 2 and 4 and 1. Yeah. You can do those.
Yeah. So that would be 0.16 and 0.12 when you multiply those two together. I have 2 6s possible too. Okay. Which would be what? 0.06 and 0.08, right? What about that 7? 0.04, nice. Okay, so watch this. Now, the predicted mean could be a little different, right? Think about it this way. If I have the mean of one and I have the mean of the other, and I combine those 2 random variables, what are we going to do with its mean? Let's combine them. That's cool. So let's say, I like that, Maddie. Let's say that as we go back, combine the 2 means to get what? 4.5. We're just predicting. Let's see what we got. What do you think we would do with the standard or the variance? Let's do the standard deviation first. So what would we do to add those, or to combine those 2 standard deviations? Add them together, right? When we add them together, what would we get from the previous 2?
Plug them into your calculator.
Yes.
So what would you get for the standard deviation on these combined?
What was the question?
So we're just finding the predicted when I have 2 random variables and I add them together. We have a mean that's combined, added together, we're predicting. And we're predicting that we add these 2 standard deviations together, right? Gotcha. Do this. We'll continue off this. I'll stop right here.
That's
I'm
not
gonna-
going to be on the quiz tomorrow.
We will do it before, like heavy. We're gonna do the quiz at the end.
How
Whoa,
long is
whoa,
the-
whoa,
how
so
long
that's
is the
gonna be
quiz?
on the quiz?
That's not good.
Yeah, but you'll be good. You'll be good. I think there's one question on there on it, but we will do this and we will review before the quiz.
Is the
No, I
quiz
understand. I'm kinda scared.
So where's your second one?
We will go to probably first lunch because we'll take the quiz out. Is that cool? So my game plan is to do to finish this before, to review, and then to take the quiz. Is that cool? Now the 6.1 stuff is on math. That may not be reviewed. Yes, ma'am.
I mean, you see the on Sorry. I know it's way too far. I want to say, I read through 6.2. Yeah.
Well, now you don't have to do that like tonight.
Yeah, but now.
I can see where you're coming from. You just did it differently than everyone else, but I can see where you're coming from.
If I get it wrong, I'm gonna get it.
Yeah, because you got these correct. I'll give that to you. I'll give that to you. Come here. Come here, Ella, we'll get you this.
And I have a question.
I'll highlight that. Yes, here. There you go.
Yeah, and do you have correct answer? Can I check the multiple choice? Because I'm not sure why this is wrong.
When I did this one, what one would you have chosen? What one is
I
it?
chose B.
Which one? Point to it.
Wait,
Point to it.
I chose this one. This is B.
That is correct. Here you go. Come here. I got you. That's what I said on that one.
Sorry, I
Choose circle the chart.
Oh, I didn't.
Does that make sense?
Okay.
Put that on the left side. I'll look at that. Okay.
And here for this one, did you count this? Because you marked 3 wrong. I'm just trying to be honest. Because you marked 3, but you just took 2 points out.
Let me see here.
And here, maybe it's right.
Mark 3, but I only took 2 off.
Yes.
This means that that's correct.
Oh.
Should have been a check mark.
Okay.
Thank you for your honesty.
No problem.
That's very rare. Thank you.
Here.
No, really,
I'm
thank
sorry,
you.
I just have too many
No, you're good.
questions.
Appreciate
here.
that.
What do you mean? Don't.
So when we do this, you're not gonna like with a random table.
Yes.
You're not gonna pick a random spot on that line. In order to execute it, you would say,
Just start
oh,
from the beginning.
177. Let's start from the beginning. Does that make sense? Because, and I know that doesn't. It seems like it's random.
Uh-huh.
But if I were just to pick a random spot on that, got me? That may not necessarily be random in the case of table D. So when to execute that or to carry out those 5 trials, I would say, okay, I'm going to start at line 177, got me? Because that's what these are right here. They're not like numbers, they're like lines. So I'd say number 177, and then I'd say, okay, 70 would represent this, 34 would represent this, 87, 28, and 71.
So you mean always start from the beginning?
Correct. Because these right here, those numbers here, are not numbers in here. They
Oh,
mean line numbers.
Line,
Does that make sense? So just to give a heads up on
gotcha.
that.
So
Okay.
I should start from here. Those
Correct.
5.
You could
And
do
I
that.
cannot start from any random place.
Correct.
Gotcha.
That's how you would execute it.
Okay.
Okay.
Should I leave it here or?
Yeah, let's put it on the left side for me, and that would be awesome. Great job. I'm proud of you.
How do you do the questions that have like 7.2 rate and then 10 of them, how many of them, what's the percent of it having the chance that
Can we look at it maybe in the morning? Is that cool? Because I got to take a look at it myself. I vaguely remember it, and I vaguely remember looking at it. But can we look at it together? Is that cool? Do it tomorrow. Let's do it tomorrow or Thursday morning. Okay.
Normal distribution. I'm good. I'm gonna monitor it, but I still get points like now.
If you come in tomorrow, I'm good with that. I will have quite a few people in here tomorrow because there's a test of pre-Cal 12. Just come here early like you normally do. And if that, we'll hop right into it. I won't mess around. Is that good? Okay. Awesome. Thank you, Matthew.
This is making more sense.
It is.